The whys and the wherefores.
An empty metal canister is heated, then the top is screwed on. Cold water makes the sturdy metal canister cave in. Did it get a shock from the water? Or is there some other explanation? And this trick never fails.
We are surrounded by air. As it warms up, the air inside the container expands and escapes. When the top is screwed on and the can is cooled down, the air left inside it contracts. So now there isn't enough air in it. The surrounding air squeezes the can until the air pressure has been balanced out, or until it meets with too much resistance from the metal.
This experiment can be repeated. The hot canister has the top screwed on and is cooled down with water. In a vacuum plant, the surrounding air is sucked out so that the atmospheric pressure around the canister drops. The air trapped inside presses the canister out.
The air in a balloon also expands if atmospheric pressure is reduced. A pump sucks out the air from under the bell jar. The air in the balloon exerts pressure outwards, blowing up the balloon. When the pressure is equalized, the original situation is restored.
The air in this bottle also expands when external atmospheric pressure is reduced. The balloon is pumped up.
The gas bubbles contained in the apple expand, and as a result of internal pressure, the wrinkled skin of the apple is smoothed out.
And in the vacuum plant, the gas dissolved in this beer is no longer influenced by external atmospheric pressure, so it leaves the liquid and causes the beer to froth.
A beaten white of egg swells up very quickly in a vacuum. The air bubbles, which make up the foam, expand because of the reduced atmospheric pressure. Something similar takes place in our lungs, which are of course filled with air sacs, if there's a drastic change in the external atmospheric pressure. The air sacs in the lungs swell and may even burst.
Atmospheric pressure falls with increasing altitude. On high mountains, this places a considerable strain on the human body.
This frog also reacts to atmospheric pressure. The air is expelled from the cavity underneath the suction pad. At first, the surrounding air holds the suction pad on the ground, but eventually air penetrates and the spring can come into effect. An amusing toy.
Here's a practical application. Here too, atmospheric pressure holds the hook in place. The air is pressed out of the cavity and the surrounding air presses the rubber hook onto the sheet of glass. And this toy works on the same principle.